Okay, so in the previous video, we talked about the overall design process for taking a scenario and producing from that by thinking about it, by reasoning about it, and potentially, if you're doing this for a client, asking the client exactly what they want. But eventually you end up with some kind of, well, what we're doing is end up with a informal data model. So I thought I'd do a more detailed example than the pizza one that we did last time, and think about something that you probably know about, and that's university. So let's say that we hated the current university system. It didn't let us enroll properly, it took too long to give us a transcript, etc., etc. Didn't do wait lists on courses, wouldn't let us check how far we progressed through our degree. So let's say that we want to completely rebuild the Unsw student information system, and it's going to involve a whole lot of things. Okay, so what kind of things? Obviously, students are involved, and courses, and degrees, and a related idea of programs. So in some sense, and I'm starting to do a bit more modelling here, but a program leads to a degree. So all of these things are interesting in the context of trying to model how a university works. Other things we need to take account of, well, we're going to run classes, and classes are going to be allocated to rooms. Now these don't exist because they're interdependent like that. Classes exist perfectly well as a thing in its own right. Now, having said things, in some of the previous examples, I think I gave the impression that things are actually physical things that you could touch, like a pizza or a store. In this case, a class isn't something that you can touch, but it definitely is a thing in the scenario of a university. Similarly, rooms are they're a physical thing. Okay, you can go to room K17103, and so we've got two different kinds of things, and we can definitely form a connection between them. So in fact, maybe I'll even draw that. A particular class is held in a particular room. Other things that we might be interested in. At the moment, Unsw is working on a system to keep track of assignments in individual courses. At the moment, we do it our own way. And the other thing that obviously is related to that are the marks that you get for assignments and the grade that you get overall for the course. So clearly this thing is got to have a connection to that, and since it's a grade for a particular student in a particular course, the notion of grade has to somehow fit as part of the connection between those two things. And you can add exams onto the kind of things that we need to worry about. Exams need to be timetabled to minimise. If we want to minimise exam timetable clashes, that's clearly an important thing, but that's going to come in a little bit later, more into the procedural side of things, once we start actually using this data model that we've developed. Other things that might potentially be interesting, faculties and schools. Ugh, looks like 5, backwards 5. Right, so schools. Also, for students, one thing they're obviously interested in is student services. And to some extent, all of these things are really examples of organisational units within the university. So the uni is grouped into 7 faculties, I think. Each faculty has a number of schools, and there are potentially student services units within an individual faculty, or once upon a time within individual schools. So these things are all examples of a particular class of thing, and there's clearly a relationship or connection between them. All right, so let's start teasing things out a little bit more. So what do we care about with students? Well, obviously each student has a student ID. Now the whole notion of an ID is an important one, and that's called a primary key. We'll talk about that a little bit later, but basically the idea is that we want to uniquely identify a student, and that ID number does that. Obviously we need to worry about your name, and we need to worry about what you're studying. So you can see that I've got the word degree here, but I've already got degree down here as an object or a thing. So what this looks like is that there's some kind of connection between students and degrees. So each student is studying at a given time for a particular degree. And that notion of time also turns out to be important in this context, because a student may, over the course of their life, study multiple degrees. So there could be several connections between students and degrees. Let's see, if we look at courses, well, courses have a code. So something like, and a title, and what else? And a syllabus, which is the thing that you see in the handbook, I guess, units of credit. So now we're starting to get quite detailed about what kind of characteristics we're interested in with respect to courses. And if I want to put quotes around these, then we're also starting to indicate what kind of values that we need to store in our database to remember these kind of things. So these are all properties of courses. What else have we got? So we've seen a few properties of students, and obviously other things that we might be interested in is your address. Although more likely these days we're probably interested in your email. So address used to be the good old-fashioned way that we'd communicate. Now I wanted to try and distinguish a little bit between objects and characteristics. So characteristics I'm going to underline in green. Hopefully it looks green on the video. So all of these things are properties or characteristics of objects or things. The things themselves I'll underline in blue. So all of these things are notions that exist independently of whether you happen to know anything about them or not. Of course, in the database, we obviously want to know things about them. Exams are things. Now, marks really only exist in the context of assignments or courses, so they're probably going to be properties, and similarly grades. Faculties and schools, on the other hand, well, they're all instances of a particular kind of thing called an organisational unit. What else can we think about here? So now we can start identifying, properties of schools and student services and faculty. So obviously each faculty is going to have a name. Generally in a database, and now I'm getting a little bit too specific for this kind of discussion, but normally we need to uniquely identify these kinds of units. In a university, in a given university, we're not likely to have two faculties with the same name. So potentially we can use the name as the unique identifier. Similarly, we don't have two schools of computer science and engineering. But I guess it's possible that there may have been some historical accident and we've ended up with a school of chemical sciences in the engineering faculty, part of chemical engineering. We've also ended up with a school of chemistry, and it happens to have the name chemical sciences in the science faculty. If we had a scenario like that, then we'd need some other way of uniquely identifying each of those schools. And the normal way to do that is to introduce some unique identifier. Right, well, that's a start about modelling a scenario like this. In subsequent videos, I'll talk about how we might convert that to a more concrete data model as an ER design and then convert it into an SQL schema.